Okay, so as you might know, if you followed any of our previous courses, I believe in minimizing the tools that you use on your local machine, and where possible, use Docker Compose or something that you can define in your code base in order to make sure all of the steps and commands that you run in your project are reproducible no matter who is running the account. So most people, they like to use Terraform installed directly on their machine. Now, there's not necessarily a problem with this if you're just working on one project or you're just playing around with Terraform. However, I don't like to do this because it means you are locked to a specific Terraform version on your entire machine. And if you're a developer that does it professionally, you might be working on many different projects, all of which use a different Terraform version. And it can be very difficult to manage which Terraform version you're running on a project. Terraform in particular has a challenge of if you run the Terraform with a new version, then it will actually upgrade your state file, which could be a shared state file for a project, to that new version, which means it's not backwards compatible. So you could run on your local machine, you can have the latest version of Terraform installed, but the rest of the project are using an older version. You then upgrade the state file to the newer version, and then the rest of the team aren't able to use their version because it has some breaking changes and it's made the state file invalid for the older version. So I like to standardize on this by using Docker Compose. So I run Terraform within Docker Compose, and I recommend you do too because it means you will have the most consistent and reliable experience when you're working on projects. And it also gives you control to specify which version should be used for the particular project. So what we're going to do in this lesson is we're going to create a Docker Compose file for running Terraform in our deploy application. All right, so let's get started by creating a new file within deploy. So it's important that this file is stored in deploy and not in the root of the project because we already have enough Docker Compose files there. If we add a new file in deploy, we call it docker-compose.yml. So this is our new Docker Compose file for our deployment. So the purpose of this is simply to specify the Docker image for Terraform that we're going to use in the course. So we're going to write at the top version colon and then in single quotes 3.7. So this just defines the version of Docker Compose that we're using here. So I like to use the latest version that we were using at the time of the course. Then we're going to define a service. So we're going to do services colon, and the service we're going to call Terraform colon. We're going to define image colon HashiCorp / Terraform colon 0.12.21, which is the latest version of Terraform at the time of recording. And again, I keep repeating this, but I must stress, please use the version that I'm using in this course when you're following the course. So if you have any questions in the Q&A, I know exactly what version you're running and I can help you better. Okay, so HashiCorp actually provide this for free on the Docker Hub. So they provide a handy release of their Terraform versions as Docker whenever they push a new update. So if you want, I can provide a link, or I've provided a link in the resources of the video for you to see the full Docker Hub list of their Terraform versions. Next, we're going to define a volume. So type volumes colon dash dot colon / infra. So what this says is just map the volume of our local directory where all of our Terraform files are to the infra directory on our running service. So when we run Terraform, it has access to our code, to our Terraform code that we create. Okay, now we're going to define the working dir by typing working _dir colon / infra, and that is short for the working directory. So when we run our service, it's going to be working from this directory. Okay, so next we're going to specify some environment variables. One of the challenges with using Terraform inside Docker Compose or inside Docker is that you need to pass through your AWS credentials that you define on your local machine. Now, I do recommend running Terraform in Docker, but I don't recommend hard coding any of your AWS credentials in Docker or in any of the files in your project. I recommend you use aws-vault, which we set up in previous videos, And this will allow you to work with multi-factor authentication when you're authenticating with your Docker via the AWS CLI. So we need to pass the user key and the secret and the temporary token that's created by aws-vault into our Docker container when we run Terraform in order to authenticate. We do that by typing environment : and then all caps aws_access_key_id equals $ and then the same thing but within this $ braces. So feel free to just copy and paste that. It's easier. And we're going to do the same for aws_secret_access_key equals $ braces, and we will paste that in there as well. And then we're going to do -aws_session_token equals, and the same again. So all this does is when we run our Docker file, when we run our Docker service, it is going to pass through the environment variable from our local machine. That's what this syntax does. It passes the environment variable that's set on our local machine into the same environment variable in our Docker container. So when we use aws-vault to authenticate, behind the scenes what it's actually doing is it's creating these variables and it's setting them in our session, and then in this file here we're passing them into our project. So that way we can get our credentials all the way from our local machine into the running Docker service without ever having to hard code them or write them anywhere in our project. Okay, so that's all we need to do. Make sure you save the file, and we're going to move on to the next lesson. Okay, so now we're ready to go ahead and initialize Terraform on our local machine. With Terraform, when you use it for the first time on any machine, you need to run something called Terraform init or Terraform Initialise. What this does is it initializes Terraform by copying the remote state to our local machine and downloading any of the required providers it needs to run our Terraform code. So we're going to go ahead and initialize Terraform through our new Docker Compose file that we just created. Before we can initialize Terraform, we need to open up the terminal or the Windows Git Bash window and run aws-vault to authenticate with our account. Now we need to authenticate with our administrator account that has access to AWS. So we created that, our AWS IAM account in earlier lessons, and we configured it with aws-vault. So we are now going to be using aws-vault to create temporary credentials for us to authenticate with AWS during this session, so during the working session that we're on right now. The way you do it is you type aws-vault exec and then the name of the account that you want to execute on. So it's mark.winterbottom. For me, it's whichever name you created inside aws-vault. Then what you do is you specify the duration. So this is the duration that you expect to be working on this account. The maximum duration that you can set is 12 hours. So it's anything up to 12 hours. The default, I think, is 30 minutes. If you know that you're going to be working on the same account all day, then you can set the 12 hours. Best practice is to set the minimum that you need. So if you think you're only going to need to do one quick change, just leave it as the default. But if you know that you're going to be working a lot on this project for a prolonged period of time, then set it to the max 12 hours. And then after that 12 hours expires, you can reset it and run it again. All right, so we're going to set it to --duration equals 12h. This will authenticate us for 12 hours. Hit enter. Now it may prompt you for your multi-factor authentication. Now, I've already done this within 12 hours, so it didn't actually prompt me this time, but you now will be prompted to enter your multi-factor authentication key, and you should enter that in there, and then it should authenticate you with AWS. If you don't get any errors or you don't get any bad responses here, then it has been done successfully. You may see an error saying aws-vault sessions should be nested with care. If you get that, then that's because you've already authenticated in the current session. So what that means is you have already authenticated and put credentials in the session that you're running in. So either what you need to do is close your terminal or command prompt /git bash window, if you're on Windows, close that, reopen it and run it again, or you are already authenticated and you can just try and run the steps. Okay, so just note that if you run this command on Windows, then you need to add --cmd.exe to the end for it to work. So if you're running it using Windows command prompt, then that's what you need to run. Otherwise, it won't store the environment variables correctly. Okay, so what we're going to do next is we are going to initialize our Terraform using Docker Compose. So type the following into the terminal or the Git bash window. Docker-compose-f, then the path to our deployment Docker Compose file. So that is deploy/dockercompose.yaml. Then run --rm terraform init. So this is quite a long command here. I'm a bit of a purist, so I like to type the commands in full every time that I run them. This helps me to memorize the different commands. However, some people like shortcuts. So if you like to take the shortcut way of the shorter commands, I provided a make file in the resources of this video that you can copy into the project. So if you just put the make file into the root of your project, and that will give you some shorter make commands, which are documented within the resources itself. But I'm not going to be using them in the course because I'm going to be teaching via the full commands, so typing them out manually. Okay, so now we can hit enter, and this will pull down the version of Terraform that we defined in our Docker file. So we're going to wait for that to complete, then it should start the service and run our application. So you can see here, it says it is initializing the backend, and now it has successfully configured the backend S3. Terraform will automatically use this backend unless the backend configuration changes. Now what it's doing is it is pulling down the providers that we need. In this case, it's just the AWS provider. It's pulling that down from the remote Git repository, and it's going to store it on our local machine. So you can see that Terraform was initialized successfully. That means that our authentication to AWS was successful as well. In case you're curious, the authentication works by aws-vault sets the temporary credentials. They are then passed into the environment variables here, and then Terraform uses them to connect to our AWS account. You can see in the deploy directory that you have this new Terraform file, and you notice that these are Git ignore, these are excluded from Git because they're grayed out. But this is basically our Terraform state, and the plugins is what contains the provider information. Now you shouldn't modify any of this directly. This is all managed by Terraform, and you don't want to be changing anything in these files. You just want to do it all through the Terraform commands. I'm just letting you know that it's there and what it's for in case you're curious. Okay, so now it's all working correctly. We can go ahead and commit changes to Git. So I'm just going to do git add dot git commit -am, and then in quotes added docker compose config for running Terraform locally. Close that. And then we can go ahead and push this up to GitLab. So I'm just going to create the new branch here. And there we go. We have initialized Terraform successfully. Now that we have our Terraform initialized, we're going to go ahead and create our first Terraform resource that we're going to deploy to AWS. The resource that we're going to create is called the AWS EC2 instance. And we're going to be using this later on in the course as our Bastion server, which is just a server that you can use to connect into your private network inside AWS for administration purposes. But I'm going to explain all that later on. For now, we're just going to create a simple instance, and we're going to deploy this to AWS. And it's going to act as kind of like a Terraform hello world. Okay. So the first thing we're going to do is create a new file in the deploy folder, and we're going to call it bastion.tf. This is going to contain the Terraform code for our Bastion service. And what we're going to do is start by defining an AMI. So I'm going to write the block out, and then I'm going to explain what all of it means after we've typed it. So type data, and then double quotes, AWS_AMI, close quotes, open quotes, Amazon_Linux, close quotes, then open the braces here, most_recent equals true, and then filter, open the braces, name equals name, and values equals, and we're just going to leave an empty square bracket here, so an empty list here. Then underneath, we're going to type owners equals, open brackets, and inside that we're going to type Amazon. When you create an AWS EC2 instance, so an EC2 instance is just a virtual machine inside Amazon Web Services. It's the most popular service and it's the main one that they started with. It's simply just a dashboard that you can use to create virtual machines on the AWS cloud. AWS EC2 instances need to have what's called an AWS AMI, which is the image that's going to be used to create this virtual machine. The image is the operating system that's going to run on it. So it's like Linux, or it could be, they have some Windows ones, but they have lots of flavors of Linux like Ubuntu, Debian, and they have their own flavor called the Amazon Linux AMI. So we're going to be using Amazon's own version of the AMI. The reason why is because it's going to be the most optimized for running on AWS because it's actually made by Amazon Web Services themselves. What we need to do here in our Terraform is we need to retrieve the ID for the latest available image. So there's lots of different images available and they're constantly updating them. And we need to find an AWS resource for an EC2 instance. You need to specify which image is going to be used to create that instance, because that's a required field for any AWS EC2 instance. The way that we're going to retrieve it is using this filter block. So what we need is the name of the image that we're going to retrieve so we can put it in this values box here. So head over to the AWS console, make sure you're logged in with your administrator and user, and then open up Services and EC2. And we're going to click on Create, Launch Instance, and then the Launch Instance in the dropdown. And you're looking for this Amazon Linux 2 AMI. So this is the one that we're after, that we need to use for our project. Okay, so what we want to do is copy the AMI ID for the 64-bit x86 version of this image. So this is the one that we want to use to create our Bastion server. And the reason we're going to copy this AMI ID is because we're going to go and look up what the name of this image is. So it's not very clear on this page, but this isn't actually the name that we need in our Terraform. We need a different type of name that I'm going to show you where to retrieve it in a moment. So copy the ID and then head back to the EC2 dashboard. And then click on AMIs next to image on the left-hand side. This will create this interface that we can use to search for images. So make sure you've selected public images in this drop down here and paste this image ID, the AMI ID, in here. Okay, so you can see now it's returned an item here. So this has an AMI name. So this is the name that we're after. We need to use this name in order to retrieve the AMIs in our Terraform. So copy the contents of the name and then head back to the code and we're going to paste it in the values here. So what this would do is it would retrieve the AMI with this name. So it would match this name and it would retrieve it and it would set it as our data AWS AMI in our Terraform that we can use for other resources. I'm going to show you that in a second. However, what we want to do is make sure when we're running the Terraform, we're getting the latest available version, which means it has all the security patches and updates added to it before we create it. We don't want to be using old versions that may have security vulnerabilities. So the way that we do this is we're going to use a wildcard. So similar to the wildcards we've used previously, where you simply put a asterisk where you want to accept any value. So you want to accept a wildcard inside the name. So we're going to remove this 202.003.04. This section here, it may be different on yours depending on the time that you are following this lesson, because they update them all the time. So you basically just want to make sure you leave the Amazon to AMI HVM 2.0 dot, and then you want to delete everything between that dot and this dash here, and you want to replace it with an asterisk. What this will do is it will retrieve the latest version of this AMI, and because we have the most recent set here, it will retrieve the most recent one. And we're going to make sure that owners is set to Amazon so that we make sure we're getting official Amazon images. We don't want to be getting any image that other people have maybe uploaded. Okay, so that's how you get the AMI. Next, we're actually going to create the resource. So come down a couple of lines and type resource, open quotes, AWS underscore instance, close quotes, then open quotes, bastion, close quotes, then add braces here, and then do AMI equals data.aws underscore AMI.amazon underscore Linux.id. And then below that, we're going to set instance underscore type equals, and then in quotes, t2.micro. Okay, so what do these lines do? So this is actually a resource in Terraform. So in Terraform, you have different types of things that you can define. One is data, and data is for retrieving things from AWS. So simply just retrieving information. It doesn't actually create or manage any resources. We're just using it purely to get things from AWS that we need for our other resources. A resource is something that you actually create. So this is actually going to create an AWS instance inside our AWS account. And in order to create our instance, we needed this AMI. That's why we had to use this data option here in order to retrieve the ID of that AMI. Now, the syntax that is used inside Terraform, it goes like this. So you have data, that matches to the data here, and then you have AWS AMI, which matches to the type of the data, and then Amazon Linux. So this is the name that we gave it. So this, we could call it whatever we wanted. This needs to be exact, otherwise it's not going to work. And then you have the attribute that you're going to retrieve. So one of the best resources that you're going to need when working with Terraform is the Terraform documentation for the image that you, or for the provider that you're using. So we're using the AWS provider. I will of course link to this in the resources of the video. This allows you to search for all of the different available features of that provider, and it gives you all the information about it. So if we click filter here and we search AWS underscore AMI, you can see that you have different options here. So you have data sources, which as I said was for retrieving data from AWS, and you have resources, which are actually for creating things in AWS. With Terraform, you could actually create your own AMI. However, we're not going to be doing that in this course. We're just going to be using the existing AMI. If you click on the data source AWS AMI, you can see that it tells you the usage of this AMI here, and it gives you all of the argument reference that you can do, which explains basically what I just explained when we were creating it. And then right at the bottom, it gives you the attribute references. So these are the things you can retrieve from that data source once it's been created. One of them is the ID, which is the AMI ID that we're going to need for our instance. Similarly, if you look at the AWS instance, if we put that into the search here, so we search for AWS underscore instance, you can see you have a data source for AWS instance, and you also have resources for AWS instance. So data sources would be if we had an existing instance on AWS that we didn't want to manage in our Terraform. We just wanted to retrieve the information from it, but we're not using that in this case. We're actually going to be creating and managing a new resource in AWS from our Terraform. So that's why we're using this resources AWS instance. It's very important to distinguish between these two because they're very different documentation. This is just for getting the information. This is actually for creating the resource. So if you click on the AWS instance here, it gives you an example of how to use it and also all of the different arguments that we use or that we can use when we're using this resource. And we use the AMI one here, which as you can see is required. So this is the AMI to use for the instance, the operating system to use for the instance. And then we also have instance type here, which is another required one that we set. Now we go back to the code. Instance type is the type of instance that you're going to use for our virtual machine. So a virtual machine has the operating system you're going to install in it and the type. So the type is basically how much resources are going to be assigned to that machine. So it can be a small machine with very few resources, or it can be a very large machine with like lots of CPU and lots of memory. I've put a link in the resources of the video to Amazon's list of all the different available resources. Now, you must note that we're using the T2 micro resource, which is a very small resource. And because we don't need to do anything heavily computational on this, we're simply going to be used to connect into our AWS account. We don't need anything heavy, so we can use the micro. You probably could even use the nano for these purposes. Now, bear in mind, that the type of instance depends on how much it costs to run this instance. So if you create a T2 micro, it's relatively cheap. You could create a T2XX large, and that would be very expensive to run. It would cost a lot more to run. And they have all different kinds of machines that cost all different amounts to run. Okay, so now we've created our Terraform. What we're going to do is save this file, and I'm going to show you how to actually run this in Terraform. So before we run it, I'm going to show you a handy Terraform feature called format. So Terraform has a very particular way of formatting itself. So basically, it wants to line up all of these equal signs. And it actually has a tool that allows you to do this very easily built into Terraform. So if you head over to your terminal or your git bash or command prompt window, and you type docker -compose-f, then deploy / and the docker compose.yaml, then run --rm terraform fmt, which is abbreviated for format. You can see it output a couple of things here. These are the items that it formatted. So if we go back to our code, you can see that it's tidied it up a bit. So it's added some spacing here, and it's also done that in our main file as well. So it's lined it up neat and tidy, and it makes it a lot easier to read. So it's optional, but I recommend you format it because it makes it a lot easier to work with. And unlike Python, this will actually format itself for you using the built-in tool. So you don't need to put much effort into making it look good. Okay, so next what we're going to do is run a similar command. So instead of format, we're going to run validate. So it's the same command. I just use the up key to get the previous command. We're going to run validate. So what this does is it validates our Terraform, which, as you might imagine, makes sure that it's valid. So you can determine if there's any errors in your Terraform before you actually push it up or you try and run it. Okay, so that's basically the cleanup of our Terraform. Next, we're actually going to apply this Terraform to our AWS infrastructure. So there's 3 key commands in Terraform when you're applying. One of them is called plan. Plan will plan out what it's going to do on the AWS account. So it doesn't actually make any changes. It just outputs the plan for the changes that it's going to make. It's recommended that you always run the plan before you run the actual apply, which I'm going to show you in a minute. So let's go ahead and run plan. So run the same command, docker compose f docker /docker compose, run rm terraform. And for those who don't know, this rm just means remove the Docker image after it's ran, because we don't want to leave it lingering on the system. It just keeps it clean. Instead of validate, we're going to put in plan. So what this is going to do is going to run through our Terraform, and it's going to compare it to our state file, and then it's going to tell us what changes it's going to make to our AWS environment when we actually apply it. So we're just going to wait for this to output, and you see it's put a summary here, so you can see that there's all these pluses here, and this is things that it's going to create. So whenever you run Terraform, it's going to either create, modify, or destroy an item, and it will summarize this in the Terraform plan that you output. So you can see here that it's going to create a new instance, an AWS instance.bastion will be created, and this is all of the details that it's going to assign to this Bastion instance. So it tells you all of the information that it's going to set up. Okay, so we can see that this plan is what we expect. So we expect that because we've created our Terraform and it's creating an instance that doesn't already exist in Amazon, it's going to create a new instance. So I'm happy with this plan. The next thing I'm going to run is apply. So if you delete plan and you run apply, hit enter, what this will do is, as you might imagine, it actually applies the changes. So this is the destructive command that would actually make changes to your AWS infrastructure. You can run plan as many times as you want and it's never going to change anything. It's a very safe command to run. The idea of it is just to get the information about what it's going to change. Plan will actually make these changes. So if you're working on a live infrastructure or you're working on an actual project, the apply command is the one that you need to be careful with, because that's the one that's actually going to change things on your infrastructure. Okay, so it's prompting us here if we're sure. Again, it's given us a summary of the plan, and this is also a very handy feature so that you can summarize it. You don't actually need to run the plan, although I recommend you do just to be safe. You can just run apply. It will ask you anyway if you want to apply this, and then I'm just going to type yes here. Okay, so what this is going to do now is going to connect to AWS, and it's going to create our Bastion instance. It can take a few moments to create the instance, but if you head over to your AWS console and you go to the services EC2, you can see under running instances that it's actually creating our instance already. So you can see it going ahead and creating our instance. Now we're gonna wait for this to complete. It can take a couple of minutes depending on the instance and where it's being created from. So we'll just wait for that to finish and then we'll continue. Okay, so now you can see that it has completed creating our instance. If we head over to our AWS dashboard, you can see that we have a running instance here, and it is running the T2 micro that we set it to run. So this is the instance that's managed by Terraform. Now, it's very important when you're using Terraform, you want to let Terraform do all of the management for you. So you don't want to do half of it in Terraform and then manually change things. So you wouldn't want to be manually deleting or changing instances if possible. Ideally, you let it all be done in one place by Terraform so there is a single source of truth for your infrastructure. Okay, so if you look at the output here, what it did is it started creating, it created, and then it completed creating, and then it gave us a summary, and it said there was one resource added. Then it released the lock. So this is the state lock that I was explaining before, which is in DynamoDB. So it basically puts a lock on the account when you're running Terraform so that you can't run the Terraform in two separate places at the same time and create conflicts. Okay, so now let's see what happens if we run apply again, because we already have our instance created. What will happen if we run the same command again? So let's try that. You see it's acquiring the state lock here. So it starts by acquiring the lock, and then at the end it releases the lock. So what it's going to do now is going to refresh the state, and it's going to tell us that our instance already exists and it's not going to be making any changes to our AWS account. You can see that it didn't even prompt us because there were no changes to make. Because our instance already exists and it's managed by Terraform and it's stored in our Terraform state, Terraform knows that it doesn't need to make any more changes. This is the beauty of Terraform. It lets you manage your whole AWS infrastructure from your source code. If we were to make changes to the source code, then it would, and then we ran it again, it would make these changes in AWS, but it would only make them the first time that you apply them. Okay, so another great thing about Terraform is it lets you create and destroy the infrastructure really easily. So we've created this AWS instance here, and now it's going to be charging us for using this instance. It's not a huge amount of money. It's a small amount of money, which I summarized earlier on in the introduction, but it's basically going to be starting to accrue costs. So it'll be like 0.01 pence or 0.1 pence or something like that. What you can do is you can then destroy the Terraform. So we can use Terraform destroy, and similar to apply, it will actually destroy all of the Terraform that is created. So it's going to destroy all of the resources that were created. In this case, we created our EC2 instance. So what this command will do is it will remove that instance. So we'll wait for it to refresh the state, and then it's going to prompt us. So it's already created a plan output here, and you can see that instead of all the pluses, the green pluses that we saw when we did the apply, they're now red minuses. So this means it is going to remove. So AWS instance Bastion will be destroyed. So this means it will be removed from our AWS. And remember, if you had anything on this virtual machine, if you were working on it, that would all be deleted because Terraform will remove everything. This is the great thing about Terraform, is it allows you to easily create lots of infrastructure and then easily remove that infrastructure as well. So we're going to type yes to remove this, and then you'll see that it starts to delete the instance. And again, just like creating, it can take a few moments to process. If you go back to the EC2 instance page and refresh, you can see that is actually shutting down our instance. Now we go back to the terminal. This can take a few minutes, so we'll just wait for that to finish and then we'll continue. Okay, so you can see that it says resources 1 destroyed. So it has destroyed our EC2 instance. If you go back to the page, it says terminated. Now it's listed here in terminated for, I believe, about 30 minutes or maybe an hour. And then this line will actually get removed. This is just to give you information about what has recently been removed from AWS. So that is our first Terraform for creating our EC2 instance. All right, so now let's go ahead and commit the changes to our Git project. So type git add dot git commit dash, and I'll add the commit message added Terraform for creating Bastion instance. Okay, and we're done.